Hello, good day. So today we shall be considering a topic titled electromagnetic spectrum. And there are three things we are going to be looking at today in this topic: how to propagate the spectrum, how to detect it, and then the uses. Okay, without much ado, let's dive in. Now, let's talk about the definition. When we say electromagnetic spectrum, it's actually the collection of different radiation, all right? And these radiation are produced by two major waves called electrical wave and magnetic wave. Consider the diagram on the screen. The blue line represents the electric wave and the red line represents the magnetic wave. If you observe it very well, you will find out that the two curves are at angle 90 degrees to each other. The combination of these two waves form what is referred to as electromagnetic spectrum, from the word electric and magnetic. Okay, now they form six different radiation as a result of their combination, and these radiation are what we are going to be considering today. All right, in this spectrum we have radio waves, we have the infrared, we have the visible light, we have the ultraviolet, we have the X-ray, and we have the gamma ray. The radio wave is the one with the longest wavelength. It ranges between 10 to the power minus 3 meters to 1000 meters, followed by the infrared wave that had the average wavelength of 10 to the power minus 6 meters. And then we have the visible spectrum, which is also called the light wave. It has the wavelength of 7 times 10 to the power minus 7 meters. And then the ultraviolet rays, which are the wavelength of 10 to the power minus 8 meters. We have the X-ray as well, with a wavelength of 10 to the power minus 10 meters. And the gamma ray with a wavelength of 10 to the power minus 11 meters. You can see, so it is being arranged from the lowest wavelength to the highest wavelength, where gamma ray is having the least wavelength and the radio wave happen to be the one with the highest wavelength, as seen in the diagram of the electromagnetic spectrum. Okay, one after the other, let's consider all of this radiation. Let's start with the radio wave. The radio waves have the longest wavelength, as we said before, but then it has the lowest penetrating power. It is being emitted by transmitters that send their signals to the radio set that we use in communication. The shortest radio wave is actually called the microwave, of which we use in our gadget today in the kitchen. So the microwave is the radio wave, the shortest wavelength. We also use this microwave in our heating elements in the kitchen as well. All right, having said that about radio wave, let's go to the next radiation in the spectrum, and that is the infrared. The infrared is the next radiation in the spectrum that comes immediately after the radio wave, and then they actually come from the sun. Okay, they come from the sun, that's their source, or sometimes from the filament of electric lamp. Now this infrared are being used by manufacturing industries, to dry paint or painted items. So it's used for drying our paints, and also it is used for the treatment of muscular problems. All right, so after the infrared, there comes the visible light. The visible light itself has its own spectrum, which are 7 in number. In the visible light, we can find the red, the orange, the yellow, the green, the blue, the indigo, and the violet rays in it. And the spectrum happen to have their own wavelength as well, where the red has the highest wavelength and the violet are the least wavelength. Now, this visible light are the source from the sun as well. Okay, it is source from the sun. So after the visible light, immediately after the visible light, we have the ultraviolet rays. The ultraviolet ray comes immediately after the violet ray in the visible light, and the ultraviolet ray is produced by mercury filament, or we can also get it from the sun as well. And then this ultraviolet ray can cause some certain material to glow when the ultraviolet ray falls on such a material. Okay, so I will say that about ultraviolet ray. Let's then move on to the next radiation in the spectrum, and that is the X-ray. You could see the X-ray are actually produced when fast-moving electrons strike a metal target. From the diagram we have there, we could see the electron stream coming from the cathode straight to the anode. And then as it hits the anode emits some particles. These particles are known as X-rays. Okay, they are known as X-rays. So they are produced when fast-moving electrons strike a metal target, which is the anode, and then produce the X-ray. The X-rays are used in the hospital to destroy malignant growth in the body and to produce X-ray photograph, which can locate broken bones. So also we use this X-ray to locate cracks in metals. If our metals got cracked, we can use X-ray to locate where the crack had come from. But then this X-ray should not be too much on the body, because too much of it on the body can cause adverse change in the blood or even lead to sterility. All right. Now the X-ray ionizes gas because of its high penetrating power. It has a low wavelength but high penetrating power, and that is why it could be used to destroy growth in the body, malignant growth in the body. Okay. Now, immediately after the X-ray, we have the last ray in the electromagnetic spectrum, which is called the gamma ray. The gamma rays are emitted by radioactive substances such as cobalt-60, uranium, and polonium. The gamma ray, just like the X-ray, also ionizes gas and darkens photographic plates. They have this high penetrating power that makes them to do this. Okay, so now there are instruments or tools that we use in detecting all of this radiation in the electromagnetic spectrum. For the gamma rays, we use the Gigamolar tube. For the X-ray, we use the photographic films. For the ultraviolet rays, we use the photographic film as well, and also the fluorescent substances. For the visible rays, we use our eyes. The visible ray is the light that we are talking about, the light ray. So we can use it. We can use our eye to see it. We can use photoelectric cell or a photographic film. For the infrared rays, we can use our skin to detect it. When infrared ray falls on your skin, you will know because of its heat. We can also use a thermometer to detect it. We can use a phototransistor, and we can also use a photographic film. And for the radio wave, we can use the radio set, television set, and the areas to detect it. All right, so these are the different instruments for detecting this wave. Now let's talk about the uses generally of electromagnetic wave. Of course, we've said some of them initially. Now, infrared rays are actually used in infrared telescope. They are used in infrared signal lamps, and these lamps are used by soldiers in fighting in the dark. We also use this infrared on photographic film that makes it easy to see even in mist and haze. The X-ray, like I said earlier, are useful in hospital to inspect broken bones, and are used in industry to inspect cracked metals, and they are also used in science to study crystal structure of matter. All right, the gamma ray itself is used to kill cancer cells in patient body. Patients that have cancer, when they are exposed to gamma ray, it helps in killing the cancer and some other bacteria in food and hospital equipment. Okay, the ultraviolet ray is used in developing ultraviolet lamps. Okay, and these lamps are useful in conducting experiments on photoelectric effect. The radio waves are very important for effective communication, so we use it in radio set, television set, walkie-talkie, and the likes. All right, so this is where we are going to draw the curtain for today. So till I come your way again, thank you for listening. Goodbye for now.